All right, here's lesson 4, adding and subtracting rational expressions. This is part 1. So when we're adding or subtracting rational numbers, you first need to determine the lowest common denominator for the rational numbers. So you look at the bottom, and if they're the same, you just add them. If they're different, then you do need to change the denominator so that you can add them. So this first one here, the denominator on the left side is 3, and the denominator on the right side is 5. And if you think through the multiples of 3, you've got 3, 6, 9, 12, 15. And if you think through the denominator multiples of 5, you've got 5, 10, 15. Okay, well clearly 15 is what we need to get to. So what we're going to do is we're going to multiply the left side by 5 over 5 and the right side by 3 over 3. And what you're going to get is 10 over 15 added to 6 over 15. Now that we have the same denominator, you can add the numerators. So we get 16 fifteenths. And we will leave it in that form. I'm not going to bother changing it to 1 and 1/15 or whatever. We'll just leave it like that. All right, 6 and 4. So the multiples of 6 would be 6, 12, 18, 24, and the multiples of 4 are 4, 8, 12. Well, how do we get to 12? Like that's clearly the common number there. So we're going to double this one, and we're going to triple this one. So you get 10 over 12 minus 3 twelfths. And now that we have the same denominator, you can subtract your numerators. So 7 twelfths. Sweet. All right, well, what happens if you have 3 terms? So think through the multiples of 8. So 8, 16, 24. Multiples of 3, 3, 6, 9, 12, 15, 18, 21, 24, and 12, 24. So clearly it's 24. So we're going to multiply this one by 3. We're going to multiply this one by 8, and this one by 2. So you end up with 21 over 24 minus 16 24ths added to 10 24ths. And now that we have all the same denominator, just add or subtract the numerators. And if you do, you end up with 15 24ths, which reduces to 5 eighths. Well, when we get into rational expressions, the same thing happens. If we have the same denominator, like all these are the same denominators, let's just add the numerators. So this becomes 9, 2 plus 7 minus 1 over x. Now don't get tempted and do 3x, okay? With fractions, you just keep the same denominator. So this is going to end up being 8 over x. And non-permissible values, x cannot equal 0. All right, here's another example. We do have the same denominator, so let's just add or subtract our numerators as for what they show. So 5a plus 3 added to a minus 6 over 2a. Okay, let's not forget about our non-permissible values. A cannot equal 0. All right, let's collect some like terms here. So we've got 6a minus 3 over 2a. And I can't simplify any farther, and so I'm left with that. Okay, again, we have the same denominator, so let's go ahead and just add our numerators. So 4x plus 10 minus 2x plus 4 over x plus 3. And our non-permissible values, x cannot equal a negative 3. Okay, collect some like terms up here. So 4x minus 2x, 2x, 10 and 4. So recall we're subtracting this. So it becomes 10 minus 4. So added to 6 and x plus 3. And if we factor the numerator, we get 2x plus 3 over x plus 3. And those will simplify to just 2. Okay, well, what happens if we don't have the same denominator? So on the left here, we've got 3x as the denominator, and on the right, we've got 6, not the same. So we need to figure out the lowest common denominator of 3x and 6. So 3x, if you double that, you get 6x. If you triple it, you would get 9x. And then 6, we've got 6, and we need to get a variable. We don't have a variable there. So what I'm going to do here is I'm going to double this one, and I'm going to multiply this one by x over x. And what you get is 8 over 6x minus 7x squared over 6x. Now we have the same denominator. So let's go ahead and subtract. So 8 minus 7x squared over 6x. Again, don't be tempted to turn the denominator into 36x squared. That's multiplication. Okay, we're not doing multiplication, we're doing subtraction. And our non-permissible values, x cannot equal 0. Don't forget about that. Okay, 8a and 12a squared. What would be the lowest common denominator? So I've got 8a and I've got 12a squared. Well, if I double this, I'm going to get 24a squared. And if I multiply this by 3a, I will also get 24a squared. So that's what I need to do. This gets multiplied by 3a, and this gets multiplied by 2 over 2. So I end up with 9a over 24a squared added to 10 over 24a squared. Same denominator, so let's add our numerators. So 9a plus 10 over 24a squared, not whatever 24 multiplied by 24 is. Okay, don't get tempted to, or change it to 48a squared. That's another one you'd see. Okay, and we will leave it like that. And our non-permissible values, not x, because we're not dealing with x, we're dealing with a. A cannot equal 0. A couple more examples here. We got 3 different things going on here. Okay, on this one I need to multiply this by a 4 and a y squared. Okay, and this one I need to multiply by 4x. And this one I need to multiply by xy, because my lowest common denominator would be 4xy squared. And let's just pause and think about, well, how did you get that 4xy squared? Well, the 3 denominators we've got are x, y squared, and 4y. All right. Well, we need at least an x in our denominator because it exists. So that's got to go there. Now the y squared, that's our maximum numbers of y's there. We need a y squared. And the 4 also goes there. So we need to figure out, well, how do I turn each one of these terms into this? Well, this one gets multiplied by 4y squared, because those are the things that are not there presently. We've already got the y squared, but we don't have the 4 and the x. And here we don't have the x or another y. So that's where that stuff comes from. And I'll do another example like that in a second. All right, so it's getting a little messy here. But the first one is going to become 12. Oops, I say 12 and then I write 4. Sweet. So I've got 12y cubed over 4xy squared added to 28x squared over 4xy squared. And the last one, we're subtracting 2x squared y minus xy. Or sorry, added to xy over 4xy squared. So let's collect this. It's getting a little greasy here, but all right, let's do it. So we've got 12y cubed plus 28x squared. Now this negative is going to distribute to both those terms, so it's minus 2x squared y minus xy. And all of this is over 4xy squared. Okie dokie. So our non-permissible values, x cannot equal 0, y cannot equal 0, and z, we don't even have a z. X cannot equal 0, y cannot equal 0. There you go. Okay. So looking between 6p and 9p, all right, if I multiply this by 3, I'll get 18p, and if I double this, I'll get 18p. So that's what I need to do. All right, this is going to get multiplied by 3, and this is getting multiplied by 2. Okay, so you end up with 15p minus 27 over 18p, and we're subtracting 6p plus 2 over 18p. So when we subtract, the negative sign gets distributed, so you end up with 15p minus 27 minus 6p minus 2 over 18p, not 36p squared or 36p, or if you're multiplying 18 by 18, also not correct. So we end up with 9p minus 29 over 18p, and our non-permissible values, p cannot equal 0. All right, so some key points. Common denominator, figure out what that is. Multiply each term to get the common denominator. Whatever you're multiplying the denominator by to get your common denominator by, multiply your numerator by that as well. Okay? And you're on to the practice.